without further ado, I'd like to introduce our speaker, Sirisha Nandipati. She's a movement disorder specialist neurologist from San Rafael. And the topic today is new treatments for Parkinson's. And so a lot of you that are here already know her. You may have been working with her on your situation. And for those of you who don't know her, I'm sure you're going to love what she has to present to us. So thank you so much.
Thank you. So it's going to be a lot of material that we're covering today, but I was invited to talk about the newest treatments in Parkinson's disease, very cutting edge stuff, and I think you'll be very excited to hear about it. I got the material from journal articles, but also some conferences I attend on an annual basis that are international. So really meeting of great researchers, really working hard to have a breakthrough in how we treat Parkinson's. So I think this will be a really exciting talk, and I'll have plenty of time for questions at the end. So just to further introduce myself, I am a movement disorder specialist, and many of you guys probably know this, but this is a neurologist who spent a little extra time training in Parkinson's disease and other movement disorders, including essential tremor, atypical Parkinsonism, and dystonia. And sometimes people meet me and they expect a dance class or a physical therapy session. And I just want to clarify that movement disorders is more of a specific class of neurological diseases. And I am the worst dancer. So I refer you to Allison Lowe and the experts in PT for a movement class. And I did my training at New York City. So I did my medical school and residency out there. And then I came back to California where I grew up. And I did my movement disorders training at UC San Diego. And I've been at KAISER San Rafael since 2016. And it's been a pleasure to serve the population. I see patients with moderate to more advanced Parkinson's in Santa Rosa, Petaluma, and San Rafael, and Marin. And even though I'm a full-time clinician, I still have some research interests, so I'm not an active researcher. I have a special interest in how the environment is known to cause Parkinson's, so that's a special interest of mine, as well as how we can change our lifestyles to prevent neurological diseases and manage symptoms. So as I said, we're covering a lot of material, so this is kind of the agenda or the map for today. We're going to go over vaccines and immunotherapy, oral medications, gene therapy, gait treatments or treatments to help with walking, and then another miscellaneous bucket, including the vibrating glove and other exciting treatments that you may have heard about. And I'm going to share the slides to the organizers, so you will have access to the slides later. But a particular note, I definitely encourage people who are in good health otherwise and able to travel to consider participating in research studies. And to help you kind of brainstorm how to do this, I'm going to go through the clinical trials, and on the slide, I have the clinical trial identifier. So you can note the trial identifier, look it up on clinicaltrials.gov, and actually see whether they're recruiting locally. And I also highlighted the studies that are running out of UCSF that welcome participants from Santa Rosa. So it's good to know the basics about clinical research as we go through all of these studies. So I'm going to keep it very simple, but there are 3 phases that a study has to go through before a drug or intervention is FDA approved. So phase 1 is the earliest stage. It's a very small phase with a few patients to really test if an agent is safe. Then there's phase 2, which is more patients are involved, and it's still mainly to look at safety and a little bit to see whether it's effective in treating Parkinson's. And then finally, there's phase 3, which is a large study, usually multiple sites, looking at safety and efficacy of the agent or the treatment in Parkinson's. And there also has to be a placebo control in order for it to finally meet FDA approval. So it's good to know, how close is this drug or this surgery available? Is it in phase 3? That means it could be approved in the next few years and be available to you. And I'm going to talk a bit about placebo. So some people may not know what placebo is. So what placebo is a sugar pill or a mimic of the active treatment. So if we have patients in a study, they're randomized to receive either the active treatment or a placebo that looks and smells and feels like the active treatment, but is not the active treatment. So if it's a pill, the placebo is essentially a sugar pill. If it's a surgery, they will actually take the patient to the OR, do a surgery, and it's called a sham surgery. So even with invasive treatments, there's still a placebo control. And the reason that's so important is Parkinson's in particular is so emotionally based. If the patient's enthusiastic about a treatment, optimistic about a treatment, excited about a treatment, that can actually temporarily improve Parkinson's disease symptoms. And that placebo effect can actually last up to 3 months. So when you look at new agents, new devices that claim to help Parkinson's disease, you really have to look at that critically and ask, was there a placebo? And did the study last longer than 3 months? So I encourage you to do that when you look at various devices that are being marketed for Parkinson's disease. And to lay the groundwork on looking at new treatments for Parkinson's, it's good to have a basic understanding of what causes Parkinson's. So this slide shows the midbrain of our brains. And on the left side, you'll see in a healthy brain that there's plenty of dark colored neurons, and those are the dopamine producing cells. And dopamine is an important chemical that helps with mobility and mood. And that lack of dopamine production is what causes many of the symptoms of Parkinson's, which is the slowness, stiffness, tremor, constipation, cognitive changes, walking changes. And a lot of the research is focusing on how to regenerate dopamine. And on the other side of the slide, you see a Parkinson's disease affected midbrain. And you see that the microglia, which are normally neurons that help fight off infection and toxins, they're very activated. And there's a lot of inflammation that's detrimental to those dopamine producing cells. And there's also buildup of Lewy bodies. And Lewy bodies are clumps of alpha-synuclein protein. And these clumps of alpha-synuclein can actually injure the brain and cause a loss of dopamine and cause Parkinson's. So a lot of the studies I'll be going through today are how to reduce alpha-synuclein, how to reduce inflammation, and how to inactivate those microglia and those inflammatory compounds of the brain. And we'll touch on this repeatedly throughout the new treatments. So the first group of treatments I'm going to go over are vaccines. So vaccines have obviously been very relevant in our pandemic, and it's kind of novel to apply it to Parkinson's or neurodegenerative disease. And the strategy for vaccines is to figure out a way to allow our bodies to clear alpha-synuclein. And there are two strategies. There's passive immunity, where an antibody or agent against alpha-synuclein is given to the patient, and that clears alpha-synuclein not just from the brain, but the whole body. Because alpha-synuclein can deposit in other nerve cells in the skin and the abdomen, the gut. It's really diffuse in Parkinson's. So there's passive immunity, giving an antibody that can clear alpha-synuclein. And then there's active immunity, which is giving the patient an agent that will stimulate your immune system to clear alpha-synuclein from your body. So it's pretty, amazing, pretty futuristic. And it's in the earlier phase of study. It's in about phase 1 to phase 2 of study. And of course, these phases are really to determine, is the vaccine safe? And fortunately, so far, it is looking like these therapies are safe, but we need larger studies again to see, are they effective?
Yeah.
And there are some anticipated challenges to the vaccine. For example, in people who had Parkinson's for many years or in moderate to advanced stages, there may be alpha-synuclein buildup that is too advanced to really benefit from a vaccine.
I doubt it.
But even if a vaccine can slow the progression of alpha-synuclein built up in later stages, it would still be an effective
You'd have to
treatment.
make
The other concern about vaccines is whether they would
not
induce an autoimmune response. And as you've heard, probably vaccines can occasionally and rarely cause autoimmune reactions, which can include blood clots, neuropathy, other damaging side effects. So that's why these safety studies are so important. And also, as I kind of highlighted in the prior slide, we're not sure that alpha-synuclein is the main process. There are other processes going on, especially with inflammation.
Or just
And
share content.
clearing alpha-synuclein may be only one piece of the puzzle.
So how is that?
So next, I'm going to go into oral pills or medication, and I put a shooting star on this slide because this one I think is very exciting. It's a drug called exenatide that's actually already in cell death. And I hope I guess you can't really see the top corner of the left, but there is a placebo control, and exenatide compared to placebo control definitely helps with motor symptoms of Parkinson's disease, even over an extended period of time. The study that is up here is about 60 weeks. So I think this is a really exciting medication. And the other couple drugs I'm going to go over, unfortunately, were not as promising. Inosine, which reduces urate and inflammation in the brain, was found to be negative in a large phase 3 study. And then iron removal. I don't know if you've come across people claiming that if you reduce iron, that will help Parkinson's. So that is, an area of interest. However, an oral medication that reduced iron actually seemed to worsen Parkinson's disease. So this phase 3 study was not successful. And next I'm going to go into the microbiome. So this is, again, I told you there's a lot of materials, so we're jumping all over the place, but I think the microbiome is a really interesting way to look at disease. What researchers have learned is that all of us in our intestines and in our gut, we have a lot of diverse bacteria. And it turns out that we need to have a healthy balance of bacteria to fight off viruses, maintain a good balance, to detox. The bacteria and the gut are very important. And it's kind of a very diverse microbiome. It's like a rainforest where all of these bacteria release chemicals that get into the bloodstream and go to the brain. And the brain can also stimulate the gut through hormones and neurotransmitters. So it's a two-way cycle between the brain and the gut. And researchers have found that in Parkinson's disease, people will have different populations of bacteria compared to people without Parkinson's. And this has also been found in multiple sclerosis and other neurological conditions. So researchers are trying to get to the bottom of, if we correct the microbiome or balance the microbiome, will that help Parkinson's? And also, does it have some positive role in causing Parkinson's disease? And so this is really exciting, but I want to emphasize that more study is needed. And on that note, there's a study you can participate at. In UCSF, they're actually doing a microbiota study. And the first goal is to just test your gut to get samples and find out what microbes are living in your gut and see if that has an association with how varied people with Parkinson's are. I'm sure looking around the room, all of us have different symptoms. All of us have different responses to medications, no two Parkinson's disease are wrong. And one of the theories is that maybe the microbiome has something to do with that diversity. Maybe if we restore one bacteria, that'll make the medication work better. These are just some theories that are out there. So UCSF is trying to analyze the microbiome and try to correlate it with the diversity of Parkinson's symptoms that are out there. In addition, they have a treatment where they give an antibiotic to see if rebalancing the microbiome actually helps with Parkinson's symptoms. So this is a phase 1, phase 2 study that you can participate at UCSF. I've had patients participate, and you don't have to be a UCSF patient to participate in the study. So I encourage you to take note of these studies in case you're interested. So for those of us who can't participate in this study, I'm sure you're curious, would probiotics be helpful? And probiotics are simple things you can buy at the grocery store, supplements that you can purchase. And I do think there's actually good evidence that it helps with constipation, which is a big problem in Parkinson's and can affect everything from, being able to eat properly and being able to absorb your medication. So I'm definitely an advocate for taking probiotics for constipation. I would definitely be sensible about it. Don't get some very pricey thing that you have to buy online. Just get a regular probiotic from your local grocery store, or even consider natural probiotics from kefir or pickled foods or yogurt. But I think probiotics definitely have some promising evidence, at least for constipation and maybe for even other symptoms of Parkinson's disease. So like I said, it's still under study. And then I'm really excited about gene therapy. So what we're understanding in Parkinson's is that Parkinson's is multifactorial. So we probably have a genetic predisposition to getting Parkinson's disease that interacts with the environment. And that's called a dual hit hypothesis, which I've touched on my last talk here, which is pesticides, heavy metals, pollutants in the environment may penetrate the body and have an effect and cause Parkinson's, but there's the genetic predisposition to allow that toxin to actually create Parkinson's. And there are 8 genes that are of interest in Parkinson's disease that have a lot to do with clearing toxins from the body, metabolizing these toxins and getting rid of waste, including alpha-synuclein or the theoretical pesticide exposure. So as we understand that these 8 genes are putting people at risk for Parkinson's, there's growing interest in developing specific therapies to correct that genetic mutation. Correct that genetic mutation, restore the function of that gene so people can properly clear and reduce the risk of Parkinson's. And on this slide, I hope it's not too busy, you can see that the mutations in these particular genes can cause increased alpha-synuclein buildup, malfunction of what we call the trash collectors of the cell or the lysosomes, increased inflammation. So if we can correct those genetic mutations, we can actually reduce inflammation, reduce oxidative stress, improve alpha-synuclein clear up, and actually protect the brain from progression of Parkinson's or even Parkinson's disease initially. And I know it's frustrating that genetic testing is not really part of the standard of care of Parkinson's because there's just so many genes to test for. So on that note, there is a national study that you can participate in. It is waitlist at this time, but I would still get on the wait list. And it's called PD Generation, where free of charge, you can be tested for the known genes that can be risk factors for Parkinson's. And ultimately, they're hoping that this will open the door to gene therapy. And I'm just going to go over a couple of genes that are known to cause Parkinson's that are under study for gene therapy. GBA1, if you have 2 copies, can cause Gaucher's disease, which is a devastating lysosomal storage disease where basically the body can't clear and the liver doesn't work to detoxify the body. And sometimes you can just have 1 copy and that was considered okay. If you have 1 copy, people live long, healthy lives and don't get Gaucher's disease. But it turns out having 1 copy is actually a risk factor for developing Parkinson's and affects almost all of the aspects of Parkinson's. So there's a phase 1 study looking at if we correct the mutations in this 1 copy, that may actually help slow down Parkinson's disease.
So the third gene therapy study I'm going to go over is also out of UCSF, and it actually doesn't have to be someone who has a specific gene causing Parkinson's disease. So this is actually a surgical study. So this is using a viral vector to put an enzyme in the brain that allows levodopa to work more effectively. And this has been in phase 3 study at UCSF, also nationally, and has been very helpful in allowing patients with Parkinson's disease to better benefit from carbidopa-levodopa medication. And on that note, as some of you might know, as Parkinson's disease advances, often people need higher and higher doses of levodopa therapy to get through their day and manage the symptoms. So in addition to that surgical therapy I just mentioned to deal with that on-off fluctuation, there's also pumps being investigated that infuse levodopa. And these are kind of in the family of insulin pumps. So these are in phase 2 and phase 3 study, and we're hopeful that this treatment modality will be available sooner rather than later. And then one of the treatments I want to look into or cover today is the treatment of freezing of gait, also known as FOG. So in atypical Parkinsonism, as well as more advanced Parkinson's disease, people can develop freezing of gait, which is when your legs get stuck underneath you, going through doorways or turns or small spaces. And it can be very disabling, actually, because carbidopa, levodopa, and other medications are less effective for treating this symptom. So interestingly, if you look at MRIs of people who are undergoing freezing of gait, there's faulty communication between the motor cortex, which is the surface of the brain, to tell the deeper structures of the brain what to do. And using transmagnetic stimulation, which is a non-invasive treatment, can help with freezing of gait. So I think this is very exciting and may help in addition to physical therapy in helping with FOG. And this brings me to the vibrating glove, another novel treatment. And I just want to put out there, there's more than one vibrating glove. One of the earlier vibrating gloves is actually a glove to counteract the tremor in Parkinson's disease. And interestingly, it's not commercially available, but that was kind of the first vibrating glove found for Parkinson's. And then there's been a lot of data, or a lot of interest, I should say, not enough data, about the vibrating glove from Stanford. So Peter Toss is a neuroscientist who did a small study looking at the vibrating glove and treating Parkinson's disease. And what's been put out in press releases that it's very helpful, but we don't really know. It doesn't seem like there's a placebo done in the study. It also doesn't know, like we don't know the duration of the study, and it also appears to be a very small study. So unfortunately, I feel like we just don't have enough information about the vibrating glove, and it really needs more extensive study to see if it's effective for Parkinson's, because you need a study that's sufficiently long enough. You also need a study that has a placebo control, and his study does not have a placebo control. So I know a lot of you have heard about this, and I want to emphasize that exercise actually does a lot of the things that these experimental treatments do. It helps increase dopamine, helps combat inflammation, helps improve blood flow to the brain, helps the brain detoxify itself. And every international conference I go to, even though we cover all of these new exciting treatments, there's more and more very good data that exercise can help slow down Parkinson's disease. And there's a lot of variety of exercise that you can do. So I really encourage you to find an exercise that fits your personality, something that you would enjoy, including boxing, you know, take part of this. Qigong, Feldenkrais, cycling, dance. And if you aren't that physically mobile, even mindfulness meditation can help with Parkinson's. And the last conference I went to, we actually did a study in stand-up paddleboarding, which is pretty adventurous, but apparently that helps with Parkinson's disease. So I just wanted to remind you about the KAISER Permanente mission. I know many of you are KAISER patients, and I love seeing familiar faces in the crowd. There's a great website for you to check out the resources KAISER offers for Parkinson's disease care. And we really emphasize a multidisciplinary approach. So every KAISER Parkinson's patient should refer to a physical therapist, just when you're diagnosed, but ongoing for ongoing care. If you have speech issues, swallow issues, you have excellent speech therapist. Even for cognitive issues, occupational therapy and speech therapy can be helpful in cognitive rehab, how to safely navigate the home. And we are having a growing team for people on very complex medication regimens. We actually have a Parkinson's pharmacist who serves a Parkinson's patient. And we actually can prescribe medication for Parkinson's disease, but we are judicious in the way we use medications because we want to make sure medication is effective and safe. So we have a judicious drug formulary, high standards of care with movement disorder specialists scattered throughout the area, including myself and Family Fowl. And I'm very proud to say we have a growing interest in integrative medicine. So if you go to the health education department, there's a lot of great classes on plant-based diet, stress management, anxiety management, sleep. So I definitely avail yourself of health education classes if you haven't been able to yet. And I'm sending this PowerPoint deck to you, but if you're interested in looking at the articles, I include my citations.